Hey guys, welcome back. This will be our final video over congruency. So we're finishing this up with corresponding parts of congruent triangles are congruent. So Cpctc. All right, so here we have two triangles, triangle ABC and triangle DEF. Now on these, you'll notice that A is congruent to angle D. AB is side 3, so is DE is also 3, and then angle B is the same as angle E. So we can write a congruency statement, and we know that these two are going to be, triangles are congruent by angle, side, angle, angle, side, angle. So triangle ABC is congruent to triangle DEF by ASA, where the side is included in between the angles. So if the side was after it, then that would be angle, angle, side, which is also just fine. We can do either angle, side, angle, or angle, angle, side. Both of those are just fine. All right, so once we know that triangles are congruent by side or angle, side, angle, we know that all the remaining corresponding parts have to be congruent as well. And that's corresponding parts of congruent triangles are congruent, Cpctc. And that's what we're learning today. So it's really kind of simple. We're just, once we prove triangles congruent by using three parts, whatever those three parts are, whether side, 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 angle, side, angle, 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 side, or hypotenuse leg, all the remaining parts have to be congruent as well. So for instance, once I have my congruency statement, in that congruency statement is all 6 parts of the triangles that are congruent, right? So you've got all 3 sides and all 3 angles. So I know angle A is congruent to angle D because those are both the first, right? Angle B is going to be congruent to E. We knew that as well. Meaning the third angle, you could also use the third angle theorem, right? So C is going to be congruent to angle F, right? So C is congruent to angle F, and that's going to be by the third angles theorem. So for instance, if this was 37, that's what's left over, right? They have to add up to 180 in a triangle. So a 53 and 90, if this is 90, the other two have to be complementary, add up to 90, and the complement of 53 is 37. So by the same logic with the third angles theorem, that means this one must be 37 as well, okay? That's also using corresponding parts of congruent triangles are congruent, okay? Because we already proved they were congruent, so all their other parts are congruent. Now the other side, for instance, BC, the last two is going to be congruent to EF, the last two. So if this is 4, it means the other side has to be 4 as well by, again, corresponding parts of congruent triangles are congruent. And then the only thing we have left is AC, the first and the last side, is going to be congruent to DF. Oh, well, I was saying E, DF, the hypotenuse here, by the same thing. Corresponding parts of congruent triangles are congruent, right? So if that's 5, that means that this one over here has to be 5 as well. All right, so here we're going to use an example with the hypotenuse leg theorem. We want to know if these two triangles are congruent. Well, we see we have a right angle, so that means we do have a hypotenuse as well. This hypotenuse is going to be congruent to that hypotenuse, which is just fine. And then in the middle, there we go. We know that this side here is going to be reflexive, so it's congruent to itself. Remember the creepy baby photo. So this leg of the triangle on the right is the same as the leg as the triangle on the left side as well. So it's reflexive, congruent to itself. And so if you notice here, we have the same angle, the same side and side. So angle, money sign, right? Now that would be the donkey postulate, which doesn't work, right? But we can use the donkey postulate, a money sign, when we have a right angle. And then if you remember, of course, call that the hypotenuse leg theorem. The reason we call it the hypotenuse leg theorem is because we have a hypotenuse and a leg. Those are the two sides that we're given, our money signs, right? And the reason they're called hypotenuse and legs are because we're dealing with a right triangle, right? And everyone remembers what's in between the legs of a right triangle, the right angle. Of course. What were you thinking? Oh, you guys. All right. So anyway, that's an example of hypotenuse leg theorem and the donkey postulate, which we can't use. All right. This is kind of fun. This kind of leads us into just some markings in triangle inequality theorem. So here, if I have an equilateral, so equilateral literally means equal sides. So all 3 sides are going to be equal. That also tells us that all 3 angles are going to be congruent as well. So on an equilateral triangle, all the angles are congruent and all the sides are congruent as well. So isosceles is going to be a 2. So we have 2 sides and 2 angles that are congruent as well. Now on this one, the two sides are the base angles. So if the 2 sides are the same, their base angles, like this angle here and this angle down here, have to be congruent as well. So there's actually kind of a property that goes on here and tells us that the opposite sides are going to be proportional to the opposite angles, and vice versa. The opposite angles are proportional to the opposite sides. You can use the law of sines to show that, which you won't learn until you take trig or pre-calc or math analysis, whatever we call it these days. But the other thing I wanted to show you here was with scaling. So all the sides are different and all the angles are different as well. Notice the smallest angle is going to be opposite of the smallest side. The longest side is going to be opposite the biggest angle. And then the medium side, like Goldilocks, is going to be opposite the medium angle. So here we have the triangle inequality theorem, which says that we can order the angles from in ascending order from the same as their opposite sides in an ascending order as well. So let me show you that part here. So the triangle inequality theorem says that if we have angles where A is less than B, which is less than angle C, so this is from least to greatest or an ascending order. So it goes A, B, C, so smallest, medium, largest, right? And then the opposite sides are going to be in the same order. So I color code them here for you. So the smallest side is going to be opposite the smallest angle. So it'll be CB. And then AC is the medium side. That's going to be opposite the medium angle. And the longest side, AB, is opposite the biggest angle, which is going to be, of course, our hypotenuse. In this case, if it was a right triangle, we'd call it the hypotenuse. All right, so that's a triangle inequality theorem. Kind of cool stuff. We would have gone into that with Unit 6. Again, we might actually end up getting able to do Unit 6 if we go back in person. So we'll try to do that because it's all done with compasses and a lot of fun. And it's a really fun, awesome part of geometry. And it would be a shame if we didn't get to do it. But we'll see. All right, so now we want to know, are these two triangles congruent? Well, we see that their hypotenuses are going to be the same because they're both 12. Then the middle here, somewhere in the middle. Oh, I guess I didn't actually mark those out. I'll do it by hand. Not a big deal. So this side CD is going to be congruent to itself by the reflexive property. We do have a right angle here. So we would have... what postulate? We have angle, money sign, right? So this should be the donkey postulate, which again, oops, that was close. I almost wrote a naughty word. If you like pause the video for like a second, that would be terrible. But in context, it makes sense, okay? And it's a good way to remember you can't use donkey postulate unless we have a right angle, and we do, and now we call it the hypotenuse leg theorem. So yes, these triangles are congruent by the hypotenuse leg theorem. We could write a congruency statement saying that triangle ADC is congruent to triangle BDC, and then all the remaining parts, this is a really important part, all the remaining parts are going to be congruent by corresponding parts. So corresponding parts of congruent triangles are congruent. So that means this side AD has to be congruent to this side BD, and the angle up here, C, is the same as this angle over here, C, and this angle on the bottom, base angle, has to be the same as this base angle over here. So all the blue parts are written using corresponding parts of congruent triangles are congruent. So once we prove that they were congruent by our hypotenuse leg theorem, we said that triangle, okay, DAC, we can do it that way. DAC is congruent to triangle, DAC would be DBC. DBC. Then after that, all the remaining three parts are congruent by corresponding parts of congruent triangles are congruent, which is Cpctc, how I pronounce it. All right, that's it. So pretty short on the lecture there, really just kind of polishing all this stuff up, and we're going to be done. So number one, write the congruency statement and list, then list the corresponding parts of congruent triangles that are congruent. So the first part we have is angle HKJ, so HKJ, that's this angle here, is congruent to what other angle by what? So if we notice this angle is going to be a vertical angle, right? So that's going to be congruent, so HKJ is congruent to MKL, so it'd be MKL by vertical angles. You can just write verticals just fine. And then now we have triangle JKH is congruent to triangle. So this is a congruency statement for the triangle. So we want to match them up. So JKH, J is going to go with angle L. So we start with J, so we're going to start over here with L. And then KM, you know, K goes with K, and then H goes with the M. That's going to be, oh yeah, what postulate did we use to prove that? Well, we have angle, angle, side. So then the question I have, is this going to be angle, angle, side, or is it angle, side, angle? So the real question is the side included in between the angles, or is it after the two angles? Well, here we have our two angles, and this side, is it in between those two angles, or is it after those two angles? Clearly it's after. So this is going to be angle, angle, side. So that's proving the triangle is congruent by angle, angle, side. Now we have JK. So everything that's remaining after we've proven that the triangles are congruent, all the remaining three parts that we didn't use to prove it, that we didn't know about, they have to now be congruent by corresponding parts of congruent triangles are congruent. Because remember, all corresponding parts of congruent triangles are congruent. All three angles and all three sides. So JK is going to be congruent to, well, you know, the easiest way to do this is actually once we write the congruency statement to use the congruency statement. So that's what I'm going to do. So JK is going to be the first two. So clearly that has to be congruent to LK. So JK is congruent to LK, and we should technically put the lines over the top because we're talking about the segments here. And that would be by corresponding parts of congruent triangles. So JK is congruent to LK by Cpctc. All right, angle H is the last one. That's going to be congruent to angle M, the last one as well. So you can use a congruency statement. You can also clearly see here, M and H are going to be congruent to each other. And then KH, so KH is the last two, right? So that's going to be congruent to KM, the last two. So that would be right here. You can see those two are going to be congruent as well. So we use all the burgundy, I guess is the color for it. Burgundy wants to say that the triangles were congruent by angle, angle, side, and then all the remaining sides and angles have to be congruent by corresponding parts of congruent triangles are congruent. And that's what we learned new part today, which you kind of already knew, but we're just applying it again at the end. All right, number 6. Given that the lines are parallel, that's what these two arrows are for, the chevrons. The lines are parallel, and R and S are going to be congruent as well. So that's what the two markings there are. So first we have TQS, angle TQS. So TQS, which is this angle right here, is congruent to angle QTR. So that's going to be these angles here. Let me mark those for you. They should be marked somewhere. Maybe, oh yeah, okay, we got it. So those angles are going to be congruent. So we want to go ahead and mark the diagram as we go when we're doing these proofs so that we can see what's going on. So don't just start marking everything that looks like it's corresponding as congruent. That's the wrong way to do this. Do it as you do the proof, okay? So we know those angles are congruent. Well, what kind of angles are they? If we have two parallel lines, they're on the alternate side of the transversal and the interior of the parallel line. So they are alternate interior angles. So you can write AIA or all AIA angles either way. And then we have QT is congruent to QT. QT is congruent to itself. It's the exact same side for both triangles. So that's going to be reflexive property, right? Everything's congruent to itself. Baby is equal to baby. Even the French mustache, bébé. Then we have Q or SQT. So SQT or triangle SQT is congruent to triangle RTQ. So that's going to be a triangle congruency statement here. That's in this case being done by angle, angle, side. Again, the side's not in between the angles, it's after it. So that's angle, angle, side. Then everything after that can be proven has to be done with corresponding parts of congruent triangles are congruent. So that means from our congruency statement that the first two SQ, so SQ, this side here, has to be congruent to RT, this side over here. And they look like it, and they are. So you can write 2 marks through that, and that's going to be by Cpctc. You can see I'm color coding as I go here. Also, ST, the first and last, is going to be congruent to RQ, the first and last. So ST congruent to RQ. Again, that's also by Cpctc. So if we notice here, we use the 3 burgundy sides and angles or whatever to prove the triangles are congruent by angle, angle, side. Then all the remaining parts, and there's one that we didn't talk about, which would be this angle here. We could say additionally, just, you know, it's a lot to write, so I didn't want to do it. We could say that those angles are also going to be congruent by corresponding parts of congruent triangles. That would be the third one. All right, number 9, and the last one we're going to do together says that given ABCE is a rectangle and D is the midpoint. So again, if D is the midpoint, that means it cuts EC in half or CE in half. All right, first part, if it's a rectangle, it means the opposite sides are going to be congruent to each other. If you remember that, we'll definitely talk about that when we get to polygons after Christmas with our quadrilaterals in our polygon unit. So AE is going to be congruent. So AE is congruent to BC because that's what a rectangle is. The opposite sides are congruent, so definition of rectangle. And then ED and DC are going to be congruent. Now, the reason for that is because D is the midpoint, so that's going to be by the definition of midpoint. Then they write a congruency statement. If you look here, we have side, angle, side, side, angle, side. Also, you could do leg theorem, which, you know, because we're dealing with a right triangle, these are both the legs, right? And the right triangle's in between, the right angle's in between the legs of a right triangle. Okay, so side, angle, side would be the way we would do that. And then we have DA is going to be congruent to DB. So on this one, DA is the first and the last, and DB also the first and the last. So we know that the hypotenuse have to be congruent as well, and we're using corresponding parts of congruent triangles are congruent. So that's how we can prove that part there. All right, well, we are done under 15 minutes, pretty short and easy. Let me know if you have any questions in the comments of Google Classroom. Make a private comment and I'll get to you there. So I'll post the practice test probably Thursday, and then I'll collect all the data from that, put the videos out, and then we'll take the test next week. Another thing is we will, I'm not sure I want to tell you that part, but we'll be dropping the lowest test score. I always do this, so we'll do it this year as well. So we've only taken 5 tests, only 4 of those will count towards your final grade. It'll still be in PowerSchool, but it won't be counted towards your final grade. So you'll notice that the grades are going to go up a little bit, but do your best on this next test, and that would mean that your next lowest test score would be dropped. Also, make sure that all of your homework's turned in. Since we're not going back, haven't decided quite if I'm going to do 60% of your homework or 70% of your homework. It's going to be is going to be worth your total grade. So I'll figure that out and put all that information in so that you can see kind of what your grades are going to be at. So anyway, let me know if you have any questions on your grades or on anything else, and I'll talk to you guys later. Have a good day.